Hi all, this is Dr. K. Lekha, Assistant Professor, Department of ECE from SRM Valiam Engineering College. So today lecture is about feedback amplifiers. Okay. So moving on, today we are going to see about what is feedback amplifier, what is negative feedback, and the topologies like voltage series, voltage shunt, current series, and current shunt feedback. Okay. What is feedback? In feedback process, a part of the output is sampled and it's fed back again to the input. Okay, so the feedback signal, that is the part which we are feeding back to the input, can be in phase or it can be out of phase with the input signal. Okay, depending on the in phase or out of phase, we have two types of feedback which can be seen in the upcoming slides. Okay, so what is feedback? The definition is the feedback is defined as a process in which the part of the output signal is returned back to the input. The output signal may be voltage or may be current. Okay, so amplifier that operates on the principle of feedback is called feedback amplifiers. The amplifiers which uses the process of feedback or which uses the principle of feedback is called feedback amplifier. There are two types of feedbacks. They are called positive feedback and negative feedback. Okay, so what is the difference between the positive and negative feedback? When the output signal, okay, so when the output signal is fed back to the input signal in phase, that is there is no phase shift between the input and the feedback signal, is called positive feedback. And in negative feedback, the output signal is fed back to the input signal with out of phase, that is with phase shift. Okay, so this is called negative feedback. When there is no phase shift, it is called positive feedback. When there is phase shift, is called negative feedback. So this is the block of amplifier without feedback. As you can see, when an input signal is fed and the output signal is obtained from the amplifier. Okay, so here you can see that the output and the input terminals are not connected in any way. Okay, so this is called amplifier without feedback. In this the gain will be A is equal to V0 by Vi, whereas V0 is output voltage and Vi is the input voltage. So next, amplifier with feedback. This is the block of amplifier with feedback. Here you can see you have an additional circuit called feedback network with beta. Here beta is the feedback factor. Okay, and the mixer, in input side you have mixer and in the output side you have sampling network. Okay, so Vs is the source signal and Vi is the input signal and V0 is your output and Vf is your feedback signal. So the work of the mixer is to add or combine the feedback signal and the source signal to get the input signal, and the sampling network work is to sample a part of the output signal obtained from the amplifier and feed it back to the feedback network. Okay, so this is the difference between the amplifier without feedback and amplifier with feedback. Okay, so here the voltage gain of the feedback amplifier is given as AF, that is F denotes with feedback, is equal to V0 by Vs. So V0 by Vs is nothing but V0 is output voltage and Vs is your input voltage, source voltage. Okay, so next, amplifier with the negative feedback. So as we have seen, we have two feedback circuits, right? So they are positive feedback and negative feedback. So in positive feedback, you have no phase shift between the input signal and the feedback. Okay, so it can be used as oscillator, whereas in negative feedback you have phase shift between the input signal and the feedback signal, so it can be used as an amplifiers. Okay, high gain amplifiers. Now as you can see in the block, so Vs is the source signal, so which is given to the mixer, and Vi is your input signal. Here inverting amplifier is used for providing 180-degree phase shift, and the part of the output is sampled, output of the amplifier is sampled, and you can see that your input signal is positive to negative and you have negative to positive due to this inverting amplifier, and it is fed back to the feedback circuit. Here you have no phase shift and you get the signal with the similar to V0. Okay, and then mixture will combine the Vs and Vf and provide the Vi. Okay, so here, So the block diagram of the negative feedback amplifier is shown here. Here VF, that is feedback voltage, is equal to beta into V naught. Here beta is your feedback factor, okay, which is given as VF by V naught. VF is your feedback voltage and V naught is your output voltage. So next, types of feedback. So in this type of feedbacks, we have four negative feedback topologies, that is voltage series, current shunt and voltage sense. It depends on the type of sampling and mixing network which we use in the each feedback circuits. Okay, so there are two types of sampling networks and there are two types of mixing. Okay, we can see it in the upcoming slides. So first type is voltage series feedback. In voltage series feedback, you have voltage sampling plus current mixing. As I said, there are two types of sampling networks, voltage sampling and current sampling. There are two types of mixing networks, series and shunt. Voltage sampling, it will be in parallel, that is shunt, okay, and current sampling, it will be connected in series, okay. So then okay, so here voltage series, the name says that voltage sampling plus series mixing, that is the mixer type used here is series mixing. You can see that the feedback network is connected to the source signal in series, okay, and in voltage sampling type, the feedback network is connected in parallel to the output of the amplifier, okay. So this type is called voltage series feedback. So the second type is current series feedback. In current series feedback, it is current sampling plus series mixing, that is in current series. So current comes from the name sampling type and the series comes from the mixing type, okay. So here you can see that here series mixing is used. The feedback network is connected in series with the source signal and the feedback network in the output side, it is connected in series with the output of the amplifier, okay. So as I said, in sampling type there are two types, current and voltage. So here, so current, it implies series connection. So you have series connection here. So this type of current series feedback is also called, amplifier is called transconductance amplifier, okay. So next is current shunt feedback. In current shunt feedback, it is a combination of current sampling and shunt mixing. So this current comes from the sampling type name and this shunt comes from the mixing type, okay. So here current sampling and shunt mixing. In mixer type, you have shunt connection. So feedback network is connected in parallel or shunt with the input source, and in in a sampling network, when it comes for sampling network, the feedback network is connected in series with the sampling network. So it is called current sampling, okay. So this is the variation between the three feedback networks which we saw. And the final one is voltage shunt feedback amplifier. In voltage shunt feedback amplifier, so the voltage, the name voltage implies the sampling type, which is voltage sampling, and the shunt implies the shunt mixing type, shunt mixing, okay. So here in mixing network, the feedback network is connected in shunt with the mixing network. So it is shunt mixing, and then the sampling network, when it comes for sampling network, the feedback network is connected in shunt or parallel with the sampling network. So it is called voltage sampling, and this type of voltage shunt feedback amplifiers are also called as trans resistance amplifiers, okay. So these are the advantages and disadvantages of the feedback amplifiers we have seen. So negative feedback stabilizes the gain. So gain stability is more in negative feedback amplifiers, and their input resistance also increases and output resistance decreases. So your operating point can be stabilized. So what is the operating point? The operating point is the point in the DC load line where your transistor can act as an amplifier, okay. So the operating point will be stable in this type of amplifiers, okay. So disadvantages are the gain is reduced and input resistance is little less in case of voltage shunt and current shunt type, and increase in output resistance in current shunt and current series feedback amplifiers. So what are the applications of negative amplifier is it can be used in electronic amplifiers and also can be used as regulator power supplies, and it can be used as wideband amplifiers where the amplifier require a large bandwidth. So this is today's lecture about the today's lecture. Thank you.